Hi all, this is Mr. Yeager looking at electric fields today. This is a pretty short topic, and on-level physics is where it gets covered. All we really need to know with electric fields is basically what do they look like if I ask you to draw them out. Which way do the field lines go between positive and negative, and which way would a positive or negative charge move depending on the electric field that it is found in. Okay, so there's really not too much. We'll probably go pretty quickly, but you know, we've already talked about that. Obviously, there we have an electric force that's formed between two charges, and just like a gravitational force, this force is a field force, which means, again, it can be done over a distance. Electric force is a field force, acts over a distance. All right, but that, in a similar way that mass creates its own gravitational field, an electric charge will create its own electric field by itself. And the idea is that field will create then a force on another charge when it enters it. Okay, so a charge creates an electric field, and then when another charge enters that, that's what's creating that force between those two charges. This hopefully then immediately makes sense that a neutral charge will not attract or repel anything because it doesn't have a field, it doesn't feel a field, it does not interact with that field, all right, at all. But if we have a positive and a negative charge, as you can see in the picture over here, you can already see kind of what we're going to do with these field lines. It shows the direction of motion. The other thing just to think about with this is we're going to go to magnets as well eventually, and this is going to be very, very similar to magnetic fields, where positive is basically going to be the North Pole and negative is going to be the South Pole with how you draw these lines. So there is some similarity. But again, in our course, we are just looking at what are these fields. Let's relate them to gravitational fields. Let's try to find some similarities and identify what the charges will do. Okay. So, again, this electric field that a charge creates will create a force on another charge. Will do work on another charge. All right. And so what we say is that when charges are in an electric field, they have what's called electrical potential energy. All right. Basically, they have that ability to now move. All right. And this is related to voltage when we get to voltage as well. This is what drives those electrons to move from one side to another and create a current. All right. And so these charges with their electrical potential energy, again, basically have then the potential to move within that field. They can convert that potential energy into kinetic and move within that field. And again, if we have a lot of these charges moving, that's electricity. Okay, that's creates electric current. Okay, we'll come back to the direction of them moving in just a bit. So, when we draw out electric fields, so one of the big things we have to understand for the test is drawing out electric fields. Positive charges, you can see how we're done with doing this. If you take your notes with it, draw the picture with it. Positive charges, the field lines are always drawn away. They're always pointing away from the positive charge. I don't want to say they're emanating from the positive charge, but the field lines always point away from the positive. All right. While on the negative side, a negative charge, field lines will always point toward a negative charge. And again, we can already then see why positive is attracted to negative. The positive, that field force is pointing away from it, while a negative charge is pointing toward it. So the idea is basically that negative is attracting that positive field, and therefore they will come together. Okay? But this is just the general way of how to draw it. Positive away, negative toward. Okay? Is what we're looking at. All right? Which way do these charges then move? Okay? Well, the idea is the positive charge is pointing in the direction of the field. So therefore, a positive charge will always move in the direction of the field, as you can again see with the notes. They'll move in the direction of the field, as you can see with this one down here. They always move with those field lines. So if you ever get any sort of field lines where they're like, okay, you have these field lines pointing downwards, and you have a positive charge. Which way will this positive charge go? It's going to go down. Okay, a positive charge always follows those field lines, while a negative charge basically acts opposite of it. Okay, again, the idea is they're pulling it toward it, so they're going to move opposite to basically grab them and yank them toward that positive charge. All right, actually, you can again see down in this picture, if I have multiple charges of positive and negative, basically what happens is I create this electric field between them. And again, we can even use this to understand that the positive is going to be repelled by the positive side, or the positive plate, while the negative is attracted by that positive plate. So the positive is repelled by positive, attracted toward the negative, negative repelled by the negative, attracted toward the positive. So again, you might just get a picture and say this charge is placed in it, which way does it go? You just have to sit there and go, okay, the positive charge will move with it. If I place a negative charge in it, it's going to move opposite of that field. All right, is all we're looking at. And again, that's just because the way those electric field lines are created amongst the charge itself, okay, how it's going to be placed in that field. Okay. Sorry, let's move on. And so that basically leads us really to our last slide already, okay? Why do charges attract? What do these electric field lines when I put these charges together, all right? So the first one we start off with, and again, you have two pictures of it, all right, basically diagonal from each other, is why does positive attract, or why is positive attracted to negative? Well, if I draw these field lines coming out of positive, and the idea is these field lines come out everywhere. All right, they're coming from all sides of that charge, just like the earlier picture showed. Okay, those positive lines would be drawn out, and the negative charge is pulling those lines in. Therefore, we are creating this force between this electric force between them, and therefore they will be attracted and move toward each other. All right, and again, you can kind of even see if I separate them out farther and farther, this is why the force will decrease, because now there's more distance, those field lines have to travel farther and farther. Basically, the greater the distance, the field becomes weaker and weaker and weaker. So that's also why the force decreases. Then on the other two diagonals, you can see why the positive repel and the negative repel. Now the positive one is easier to kind of see. The idea is both of these charges want the arrows pointed away. So if these two arrows are coming toward each other and they don't have a negative anywhere, they're going to basically curve away from each other, creating a repulsion between these two areas. And we actually have a dead zone in here, all right, right in the middle there, all right. But essentially, the charges are pushed away, and so then there's actually no field lines. If you actually place a charge in here, what will happen is it actually won't do anything, just like with a magnet, same idea, okay? It'll get repelled by that in some ways. Actually, never mind, that's not true. Incorrect statement there. Don't say, I'm thinking of magnets. Magnets, that works. In the electric field, that could still work. They could still get attracted toward it. Looking at the repelling of the negative charges. For the negative charges, same thing. Basically, those lines are being pulled toward their the two different negative charges, and they create a repulsion between those lines because they are moving basically opposed to each other. So sorry about that statement back here. What we want to say basically is that positive will repel. Okay, come on. Oh, sorry. Positive will repel. Those lines basically curve up, and we create a repulsion between them. Okay. Negative and negative also have that curving motion toward each individual charge, and that creates a repulsion factor as well. If you do place a charge in here, I will go ahead and say it will attract them, and you will have an attraction occurring between those two. Okay. There could be repulsion that occurs around it, is what I was referring to more, but we don't need to get in that much detail with it. Okay. So that's really it. So I mean, main ideas. Be able to draw just a positive charge and draw which way the field lines are going. Draw what the field lines are doing in a negative charge. Which way does a positive and negative charge move within a field? Positive always with, negative opposed. and then being able to look at these diagrams or even draw them out of why does positive negative attract and positive positive negative negative repel. And that is